Here we're going to take a look at properties of parallelograms. To start with this, we're going to start with two parallel lines and a transversal. We know from earlier lessons that two parallel lines cut by a transversal, their alternate interior angles are congruent. So we can go ahead and mark these two angles as congruent. This is going to give us some of the base of what we need to get started with the idea of these parallelograms. So a quadrilateral is a parallelogram, then its opposite sides are congruent. This is the first theorem that we want to be capable of proving. So what we need to do is we need to go ahead and construct the rest of this parallelogram by simply giving ourselves a parallel line. So what I'm going to do is I'm going to put up a parallel line that cuts through those points. So we'll mark these as parallel just so that we have it. And in order to be able to discuss this, we're going to give the intersection points names: A, B, C, and D. So what we're going to do is we're going to think about parallel lines and just try and line up angles for what we have, and let's gain all the information we can from this picture. If I'm looking at these two triangles to start with, I know that the center is congruent to itself. So BD is congruent to itself because it's a shared side of the left and right triangle. I know that these two angles are congruent because of these two parallel lines. Similarly, I know that this angle is congruent to this angle because if I concentrate on these two parallel lines cut by this transversal, then the same alternate exterior angle. So I get angle side angle congruence to show this triangle is congruent to this triangle. That's very convenient for me because now I can say that this side is congruent to this side because of angle side angle, and this side is congruent to this side. So I'm able to show that my parallelogram, the opposite sides are congruent. I'm able to show angle congruencies. The triangle angle sum theorem says that since these angles are congruent to each other, the third angle when added to these two must add up to 180 degrees, meaning this angle must be congruent to this angle. So I'm able to show that if a quadrilateral is a parallelogram, its opposite angles are congruent. This very same thing, let me go ahead and show this on the two triangles. But what if I added another side? What if I added another diagonal to this picture? So if I added a diagonal from A to C, what I would create is a new triangle, a new pair of triangles. So what I want to think about is this really small triangle here, and this really small triangle here. So to really go through this nice and easy, this is a parallelogram. This is a given piece of information for us. AB is parallel to DC, which means that AB, let's call this center point E, ABE is congruent to CDE, things we've already known, and BAE is congruent to DCE. So we're just establishing this. Because this is a parallelogram, I know that AB is congruent to DC. I'm building my angle side angle argument all over again. So what I know about the angles and what I know about these sides means that I'm making angle side angle congruency again. Congruent parts of congruent triangles means the two triangles are congruent. So what I get is angle side angle, angle side angle. So that means that this side right here, and I'm just going to put a 4 on it, must be congruent with this side. And I'm going to put a 5 over here for this one, must be congruent to this one. So what I'm also seeing here is that this line, this diagonal of my parallelogram has been bisected by the other line, the other diagonal. And that diagonal is itself bisected also. So there's a number of things I get here. Out of this picture, I get that opposite sides are congruent opposite angles are congruent, I get that the diagonals are bisecting each other. So this is some of the stuff we get about parallelograms and how we can use that information later to be able to prove stuff all using triangles, all using the parallel lines and transversal theorem that were taught very, very early in this geometry series. Remember, math rocks with a capital M.